Welcome to Spring LIB.
Right. So the question was asking us, how far is this mass from the equilibrium position of the spring when the elastic potential energy is equal to the kinetic energy? Which means it's asking us to find out the displacement when the kinetic energy is equal to elastic potential energy. Okay, which is 1/2 mv squared equal to 1/2 kx squared. We know that v is equal to omega times square root of a squared minus x squared. V is the speed here, omega is the angular frequency, a is the amplitude, x is the displacement we're looking for. And we know that omega, which is the angular frequency, is equal to square root of the force constant divided by the mass, which is k over m here, okay? And if we plug in back to the v equation, so we use the square root k over m, substitute for omega, we get that v is simply equal to square root k over m times square root a squared minus x squared. And which means that v squared is equal to km times a squared minus x squared. Okay, if we plug in back to the original equation here, we get a 1/2 m v squared, which is 1/2 m times k over m times a squared minus x squared equal to 1/2 kx squared. And you see here m and m cancel out, we get 1/2 k a squared minus x squared equal to 1/2 kx squared. And in this case, you see 1/2 k and 1/2 k cancel out, so which means that a squared minus x squared is equal to x squared. So a squared is equal to 2x squared. Okay? So we know that since a squared is equal to 2x squared, so a is equal to square root of 2 times x. So displacement we're looking for is equal to a over square root over 2, or if you want to make it look a little bit nicer, which is square root 2 over a over 2. Okay? So that's the answer for this question. Thank you.